the honour of presenting on behalf of the team, along with Branko from FDC. Just before we get into the building, we just wanted to talk briefly about the team, and we've got a few team members who've come with us along from all the way from Sydney, Australia. So we've got Don from Zuri, who looked after the concrete on the project, Garrett from FDC, and David Mahaffey, who was our concrete guru for the project. This project, more than ever, was a group effort. I think one of the best things that FDC did was bring a team together to work on a project, and there's obviously dozens and dozens more people, from consultants to subcontractors, who really pulled together an amazing effort for this project, and yeah, I felt lucky just to be a part of it. So onto the building. The museum was constructed by the University of Sydney to house some of their artefacts and elements and pieces of art that they currently had not on display. So it both stores and displays, and also has some multi-purpose teaching spaces. It's a 6-storey structure. A fair bit of that is underground. It's built onto a sloping site, very close to a number of fig trees that remained throughout the project. Obviously, the most striking feature of the building is the off-form concrete walls, affectionately known by the team as the box. So from level 4 upwards, there's 4 perimeter walls that cantilever out in each direction that are both the structural finish walls, as well as forming the facade of the building. Aside from the box, there was a number of other pretty complicated elements within the building, including 2 long-span stairs, one out of concrete, one structural steel, a lot of decorative precast within the building, both internally and externally, exposed concrete soffits right throughout the building, again, internal and external. And I've included Hathor there, which is one of the key pieces for the university. Because part of the building brief was that it would just have a 100-year design life. So it's not quite as long as the 2,800-year-old Hathor in the middle there, but that not only posed some durability challenges for the structural design, but for the whole project team, we knew we were working on something that was going to outlast us and that would be there, and also a public building. So if you ever happen to find yourself in Sydney, only a quick 15-hour flight away, you can drop in and walk through the building, which I really recommend. Now onto the building itself. So this is a cross-section of the building you're looking at here. So we've obviously got several levels underground there. But the real action, and what we'll be talking mostly about today, is the box structure up the top that starts off at level 4. So there's a 9 metre or 30-foot cantilever to the west, and then on the eastern end you've got the large 14.2 metre or 47-foot cantilever that forms the front of the box structure, with level 5 dropping out to form a double height space. But this cross-section actually doesn't tell you the full complexity of what the structural design looks like, because it's actually a little bit worse than that. So bear with me here, you're looking at a level 4 plan, so that was that yellow line we looked at before. The orange walls are the box walls, so they're 400 thick concrete in situ walls. And then the pink ones are called flexure walls, so they start at level 4 and they provide support to the box wall structure. And then finally the green elements are our vertical support. So just kind of trying to work through a little bit. If you can imagine you're standing in the middle of where it says 14.2 there, you're in the main gallery. You're standing on a suspended slab there that spans, on one edge is hung off the pink wall, which spans between the concrete columns, which is relatively straightforward. And on the other end, you're supported, again, hung from the box wall, which itself spans 33 metres or 120 foot out to the tips of the long box walls. So then the long box walls cantilever off the 14.2 metres back and are supported not off a vertical support, but off another cantilever, which is, again, that pink wall. And that's pretty well the concept there for the box structure. So you're now looking at an elevation of one of the main walls with some of those slab elements shown in yellow, the box walls in orange behind that join in, and then the flexural internal support walls shown in pink. Well, now this is a copy of one of our structural drawings elevating the reinforcement of the walls. Obviously quite a bit of detail there that I won't go through. You've now switched to be looking in from the inside view, so for these studios it's kind of mirrored around. But without going into too much detail, one of the key considerations here was trying to detail the reinforcement in such a way that it worked with all the construction detailing. So not only were we trying to reinforce the walls to deal with the loads that we had for strength, but also trying to figure out control cracking and limit that cracking quite considerably to deal with durability, but then to make sure that we could build these construction joints and that we could get vibrators down into the walls. So it was a real collaborative effort from the whole team to figure out that detailing. Once the engineering design was done, there was probably that much work again to go through with the whole team about figuring out how we're actually going to build this and how we're going to detail it. So mammoth effort by some of our team on that. So that was the reinforcement, conventional reinforcement in the walls. This is a plan showing the post-tensioning in that same elevation. So we had two types of post-tensioning. We had what we would call in Australia conventional post-tensioning, which was strands inside of ducts. And then along the top of the wall, we had a high tensile McAloy bars that were stressed at either end. So if you look closely at some of the photos, there's a small little stainless steel cover plate where those are stressed at the top of the building. Before I hand over to Branko to talk about some of the construction challenges on the project, just a couple of structural details. So on the left, we're looking at some of the anti-burst for the McAloy details, and then on the right, that's a planned view of one of those connections of the flexural walls back up to the outside box walls. So there's quite a bit going on there, and I have to give a special mention to Aaron Cook, who detailed a lot of the walls, and had many late nights preparing many details. So I'll hand over to Branko now, who will talk a little bit more about the construction of the project.
All right, so dealing with the construction, so you can see there, obviously, these are the action shots taken, obviously, actuals of the building opposite the old library, looking over what we were doing there. So the box was cast in 24 segments, so essentially where we started was the four corners. So we did those, and then there was the infill in the middle, so, and then you did that 3 times. So 24 segments of concrete were poured just for the walls themselves. And they were generally 400 thick, which Aaron did mention earlier. Now another feature of the project was the incorporation of the precast elements. So they were all decorative, so there's nothing structural about these panels that you see there. They're purely architectural. They originally planned to be installed following the completion of the structure. Now that wouldn't work because they were just far too large, and they were also decorative, and it was the finished product. So we needed to build them in situ and then build the structure around. FDC embarked on a sequence-driven methodology, installed as we were building, and as I say, the protection was the key. So all that timber paneling is purely for protection of the precast. As Aaron mentioned, there's a couple of the reinforcement details. You'll see it's a different colour here in that bottom shot, and on the outside skin, that's all galvanised reinforcement, and that was again driven by the 100-year design life that we were contracted to. So casting of the box required countless considerations. Class 1 is generally precast concrete, and Class 5 is what you put your formwork in, footings and things like that. So we were contracted to deliver Class 2. Shutter systems, so all our shutters, all our formwork shutters that you see there on that bottom shot on the left-hand side, it's 2 layers of plywood for the finish face and overlapping joints to avoid the bleed. Construction joints were a combination of tension couplers and lapped joints with stop ends crafted like joinery to thread the starter bars through. And again, just all that is to stop the bleed that we were getting, that you typically get in concrete walls. So reinforcement detailing, we even went to the point, also as Aaron mentioned, of drawing the reinforcement at 1:2 scale, so we can actually practically see where our vibrators were going to be placed and things like that. So you can imagine that detailing there. So that's the top of the wall there, and how we were going to build that. Concrete supply chain issues as well, so batching and delivery times have to be considered. The pumping considerations, we used a boom pump for all of the walls. Additives including Green Star requirements, placement methods and those conventional vibrators and curing. So the big question was curing and how are we going to control colour. So there was many different versions of curing that we considered, but at the end of the day, what we landed on was we actually kept the shutters on the walls for 4 days, and consistently on the 4th day we were taking them off. And I think it was a pretty good call when you look at the consistency of colour that we ended up with. Propping was a real headache for us because as the box was being cast, it doesn't obviously work until it's fully complete. So time constraints were massive for us. So you'd finish a basement, but you couldn't start the services or anything in there because all these props were in the way. So appreciating the need due to the monolithic action of the box design, like an arch bridge, but opposite. Propping needed to consider founding material also, so some of these props are landed on the actual slab themselves, but some are also on earth. So there were plenty of additional temporary piers that were placed around the perimeter of the building to make sure that all that propping was working as it should. It took 9 months to develop the right concrete mix. Shrinkage, colour control, hydration, temperature, thermal expansion, and cement composition were all considerations in the mix design. Water demand and workability factors as well. So that, what you see there on the left-hand side, that's our prototype. So and this was obviously done before the first wall was even cast, and we tried to incorporate everything that you see in that box on that prototype. And we even went to the point of visiting the local batching plant and the backup plant and did audits on what they were, how they were doing their batching and their plant systems. And on-site monitoring of discharge times also, there was a heavy emphasis on that as well. And I think that's about it.